Hi there, this video is part of a three-part series. In this video, we will teach you the kubectl commands. We have a unique approach to Kubernetes training. We start with a demonstration of how to deploy a web server using only the Kubernetes kubectl commands. Then we delve deeper into the Kubernetes kubectl commands. If you watch this video to the end, you will be glad, as no one teaches Kubernetes this way. Now, now let's get our hands dirty. In this demo, we are going to install 2 instances of an Nginx Webserver into our Kubernetes cluster. Before we start, a quick word about namespaces. Think of a namespace as like a virtual space on a server where you can put objects. In our case, our namespace is where we are going to deploy our web servers. We are going to have 2 instances of Nginx, and we are going to deploy them inside our namespace. It is advisable to always deploy your applications inside namespaces. Otherwise, you'll end up with bits and pieces of uninstalled or broken installations scattered across your cluster. So let's copy this command and then I'll explain it. Kubectl create namespace. Whenever we want to create a Kubernetes object, we always are running the command kubectl create. And in our case, our object is a namespace, and then we give it a name. After running this command, this is what we got. Namespace, and it said it was created. Now that we have our namespace, we can now use this to deploy our web servers. Let's carry on. Now, the quickest way to deploy an application is to use the kubectl create deployment command. Then you give it an object name, my Nginx, and then we specify the Docker image. This is coming out of dockerhub. It will download that image from the dockerhub repository and then install it in our cluster. Additionally, we can add the number of replicas. In this case, I would like to have 2 web servers, so I'm going to specify -- replicas, and then you can either do -n or -- namespace, and then specify the namespace. Instead of -n, you can use -- namespace to specify the namespace, as I have done here. And we have now created our deployment. Next, we need to verify that. So we can run this command. I'll explain this. We are saying kubectl get pods. Now, when we deploy an application, it will create pods. And because we asked for 2 replicas, we specified replicas equals 2. We should now have 2 pods. You can use the long namespace, or you can use the shortened form, -n. So let's run this. And now we can see that we have 2 pods. What is interesting to note, the names that the pods get begins with the instance name. When we deployed our Nginx, we specified the name that we wanted for our deployment as my Nginx. So that's what we got here, as well as a randomly generated ID. The reason for this is that Kubernetes wants to ensure that you always have unique IDs for your pods. Now, this command is not very useful. It only showed us the names of the pods and that they are running. What we can do is run the same command but add another parameter. If we say -o and then say wide, you will see now we will get a lot more information. Watch this. So in addition to what we got before, we now have the virtual IPs of these two pods, as well as on which nodes they're running. Now this node here, the name of this node, this is our master node in Kubernetes. K3S calls it the server. And then this is our worker node. K3S calls this the agent. And we can have multiple agents. You will see now. There is another command we can run, kubectl get all. In the terminal, we see a lot more information now. Now we can see the information about the pod, which we just saw previously, as well as the deployment. And because we specified replicas as 2, there's even a replica set. And it says desired 2, and currently we have 2. So that's what we get when we run kubectl get all. And I'm specifying all the objects in my namespace. Now, if I run the same command like we did previously, and we say -o wide, I'm going to clear the screen and run it again. Now you can see a lot more information. We got the information about the pods like we got when we used -o wide. But in addition to that, we got information about the replica set. It told us that we are running a Docker container Nginx, that we are using the Docker image Nginx. And we can see that we now have 2 Nginx Webservers running in our cluster. Imagine you were trying to run your website in the Amazon cloud, and we now have 2 web servers in the Amazon cloud. In the mornings and late evenings, you won't need many pods, so 1 or 2 pods would probably be suffice to keep your system going. During peak traffic time, you may need 100 or 1,000 instances of the Nginx. It is expensive to go and deploy 1,000 pods into the Amazon cluster because you're going to be paying for every pod that's running. So we need a mechanism to be able to control that during time of low usage, we only want to have a few pods, and during time of high demand, we want to have enough pods to handle the load. So this is the reason we are going to use scaling. I'm going to copy this command but I want to have more. If I increase this to 4, it says now my Nginx was scaled. And we can see now we have 4 pods. And if we look carefully here, you can see each one is on a unique node. So I've now managed to scale my number of servers across all my nodes in my Kubernetes cluster. And during low usage, we may want to scale downwards. So let's scale down again. So this could be a mechanism that you could use to manage your Amazon cloud manually, scaling up and scaling down the nodes in your cluster. The way Kubernetes works, your nodes are not connected to the network, and we need to use a service to connect your nodes to the network. So this is the command that we would use. And let me go through this command. The first part here is where we create a service. Now here we tell it what the service type is, and here we want to use a node port. And then, like when you create any Kubernetes object, we always give that object a name. So this is the name, and then after that we want to give it some networking details. So we want this to open on port 80, and then here the good practice, always deploy your pods and anything that you create inside a namespace. So that's what we are doing now. And when we run this command, we can see that we have created a service called Nginx, and it has a virtual IP. That's the virtual IP of the service. We are mapping port 80 for this service. I should now be able to open this in the terminal. We use the curl command. The curl command you would probably call the terminal equivalent of a browser. So you would run this command, curl, and then the URL. So in our case, that is our master node, or server as it's called in K3S, and then that's the port. And we can see we've succeeded to open it. We should also be able to open that URL in the browser. It was great to see the web server open up in the browser. Like after a chef has prepared a meal, you need to go and clean the working space. In our case, we need to clean up our cluster. And this is the reason why we use a namespace. If we didn't, we would have to go and say kubectl delete and manually delete every object that was installed in our cluster or deployed in our cluster. But because we put everything inside a namespace, this is the command we are going to use. Kubectl delete namespace, and we delete our namespace. Now that we've deleted the namespace, we want to prove that we haven't got any bits and pieces left in our cluster. So I'm going to do a kubectl get all command. But this time I'm going to tell it all namespaces. You see, when you used a -n or a double dash namespace, you were filtering so you could only see what was inside a specific namespace. But now when we use the double dash all dash namespaces, we will be able to see everything. And we can see that we only have the kube system in here, and that's good. The kube system is part of Kubernetes. In our particular cluster, it's the K3S Kubernetes. Having done that, let's start the next demonstration. Like we did previously, we create a namespace. So we will copy this command, clear the terminal, we've created the namespace. We're going to do a similar deployment, except I want 2 replicas. And I'm going to do the kubectl get all, but this time I'm going to specify my namespace. And we can see we have 2 pods. Nothing new now. Everything we've done so far is as per the previous demo. But now we're going to introduce a very useful feature if you were putting your web server into the Amazon cluster. Now you don't have to wake up at midnight and early in the morning to go and scale up and scale down. We are now going to learn about auto-scaling. Basically, it's a kubectl auto-scale command, and then we specify our deployment. And our deployment is this here, deployment Nginx. So that's what we specify. We also specify a min and a max. So this will enable us to run scaling with a minimum and a maximum size. If you run this command as it is there, it's not going to be very useful. We need another parameter, and that you'll find in the next line. So let's copy this command and explain it. Now let's have a look here. I have an additional parameter, CPU percentage. Now how this works, if any pod is busy, the amount of CPU usage will increase. Because our pods are web servers, as more traffic comes into that web server, at a certain point we will exceed 50%. The minute that happens, the autoscaler will detect this, and what it will do, it will immediately increase the number of pods. So it will do additional deployments automatically. It will also increase and up to a maximum limit. So I've set my max as 10, but you are paying Amazon to host your web service. So for you, maybe 1,000 might be the cost-effective value that you want to have for peak traffic time. And maybe even the minimum, you may want to have, say, 50 for the minimum. So you've got quite a range. In other words, you've got quite a range of web servers deployed in your cluster for a production environment. So let's run this command. And it's auto-scaled. And let's have a look what we have there. And you can see now we've got a new thing added to our deployments here. We have the horizontal pod autoscaler. We've specified a minimum pods of 2 and a maximum pods of 10. If you look here, we are running the minimum number of pods, so that is good. We actually have 2 pods running in here. There will be no need to autoscale in the cluster right now because we don't have CPU usage. And once again, we clean up. So we run the kubectl delete command, and we've now cleaned up our cluster. You'll notice it takes a few seconds for this to happen because it does 2 things. First, it's deleting the namespace, but it's also undeploying everything that was deployed in the cluster. So it's not just wiping out a namespace, but it's also doing cleanup. And that is the reason why we want to put things inside namespaces. Also, it allows us to have logical separation in the cluster. So I could create a namespace for databases and a namespace for web servers. And let's now continue with the lesson. Now that we've completed the 2 Nginx demos, we are now going to be looking at this page and learn about the kubectl commands. Kubernetes gives us a whole range of kubectl commands. Think of the kubectl as the API, and then this API is a very rich API, and it's got a lot of functionality which we have categorized on this page. Let's begin with the first category, namespaces. We've already seen how to create a namespace, how to delete a namespace. We've used the get commands, filtering with get all and filtering that with either the namespace spelled out or the shortened form -n. The next category is creating objects. We've also seen this when you run the kubectl create, you are able to create objects. In our case, we created deployments and we created services and other things. So kubectl create. And then when we created the deployment, we could use the get deployment or we could use the get all command. We also learned to do our deployments inside namespaces and how the cleanup greatly facilitated that when we ran the kubectl delete command. The next category is to create services. We created services where we specified the server type and the networking details, as well as we put it in a namespace. There are different ways to expose a web service. The best is to use kubectl help expose. Let's run this command. And then this gives us quite a lot of information and a lot of parameters that you can use to expose the service. There were different types of service types. We used node port, but there is also a load balancer. Load balancer is a service type where you're using an external load balancer that's configured to communicate with your cluster. For our Amazon web project, this is what you would use. Amazon sets up their own load balancer and it would be configured to communicate with our cluster. So for your 1,000 pods that are auto-scaling, the load balancer will pick up the pods and share the load equally across them. The other type of service type was node port. We've already seen node port. One of the things you need to be aware of, normally when you work with node port, you are working in the range 30,000 plus. So 30,000, 31,000, 32,000, it's in that range. There is another networking type. This is not available in the kubectl command, and that is ingress. In the previous lesson 1, when we were learning about Kubernetes Manifests, we took a Nginx server and we created the Nginx manifest, and we were able to open the cluster through the Nginx on all the nodes using the Nginx to do the networking. Whenever you create a service, there will always be an endpoint, that is, a URL and a port, as we have seen before. So the kubectl get endpoints command is quite useful to reveal to us what endpoints are available. And if you do get endpoints all namespaces, then you can see all the services in your cluster. Or in our case, you could say endpoints -namespace my Nginx. That will allow you to only see the service endpoints for our namespace. There is also a variation of the -o command where if you say kubectl get an object, like we were saying get all, and we said -o and then we said wide. But you can also output as a JSON formatted text. If you say -o JSON, it will show the information that you are looking at, JSON formatted information. And likewise, if you say -o YAML, it will display the output as YAML formatted text in your terminal. We could use that to get all the endpoints as a YAML formatted document. Now, these are very useful when you want to document your infrastructure so that you know that we are connecting to the right ports, that the load balancer has got all these pre-configured in it. Then you would use a command like kubectl get endpoints. The next category was scaling resources. We already saw this. We saw two versions of this. We saw kubectl scale, and we also saw the kubectl autoscale. the category viewing and finding resources is something that we've been using quite extensively. We were saying kubectl get all and then specifying a namespace. We also did get deployment or get pods. You could say kubectl get pods, all namespaces, or for a specific namespace. This is what we were using. So the get is quite an important feature of the kubectl commands. Now describe, if we have I can run this command now, kubectl describe nodes. Deleting resources is quite an important category. We've been deleting namespaces. By putting my deployments and my services inside the same namespace, I was making it easier because I could clean up by deleting the namespace. If you don't deploy inside namespaces, then you got to use a kubectl delete pod, kubectl delete service, and you have to go and manually find all the objects that were created in your cluster and manually delete them. So that's what you can do with the kubectl delete command. The next category is very useful, interacting with running pods. What we are able to do, if you use the kubectl exec command, you are able to run commands inside your pods or inside your containers. So you would specify the pod and then you are able to run a Linux command. Here we are able to use this command, a Linux ls command, which would then list the whole directory. And with this command here, we are able to open our terminal inside the pod. So we can then run Linux commands inside the pod from our terminal. So you can see these are very useful commands for certain types of servers. Elasticsearch is probably one of these. When you deploy Elasticsearch, you need to go in there and set up your passwords and keys and public keys and private keys. And it's very useful to be able to run Linux commands to do that. Apart from the exec command, kubectl logs is also a useful command for getting information from the pods. Any deployment running in your Kubernetes cluster will have logs. And even when you created your cluster, your nodes will also have logs. So by using the kubectl logs command, we can go and look at different logs of different objects. So here's one command where we could look at the log of a pod. Obviously, if you can remember, the pods have unique IDs and you have to type that unique ID in there. These are very similar to Docker commands. So where you said Docker run, you can also say Kubernetes run. The next category is the mechanism for copying files to and from containers. So with the kubectl cp command, I can take a file in my local directory or my local directory, whatever's inside my local directory, and I can copy that to a pod. Notice that this looks like a URL. It's the pod : and then inside the pod is a relative path to a folder inside that pod where you can copy to. And if you reverse these around and you said my pod and then you copied this after this, if you swap them around, you could do the opposite. You could be copying files from the pod outside to the file system. So this is a very useful mechanism for updating certificates and things like that inside the pod, where you can copy files to and from. Dry runs is an important category. When we were deploying Nginx, because Nginx is a trusted Docker image that many people are using and it's well maintained, I would run that with the kubectl deploy command. However, if you have an unknown or untrusted image that you wish to deploy in your cluster, the best is to say create a deployment like we would do, but then put the parameter dry run. What this does is Kubernetes pretends to deploy the application, and it will read the files, but it won't write to the file system. But what it will do is, while it's pretending to write to the file system, any errors occur, it will display. So if you do a dry run and you don't get errors, then you can trust that and deploy it. So that is an important thing to consider, especially on your production server. Your colleague created an image, do a dry run to see that you're not going to have problems deploying that in the cluster. It's better to know there's a problem than to find it out that it doesn't work in my cluster. Make it my friend's problem and not mine. I'm going to demonstrate some of these commands, but I would like this to be homework for you. So let's start with the first one. Let's create this namespace. I'm specifically calling a very specific Docker image here. One of the problems with running containers is they run as root, and sometimes that can be a problem. It can be a security risk. So here is a Docker image of Nginx that does not run as root. So if you ever need to do that, this is an image to use. Notice that it says container creating. I should run this again a few minutes later. And you can see now it's running. Obviously, this was a very busy Nginx, and it took a bit more effort to get it up and going. We mentioned the kubectl expose command, and here we are specifying a protocol of TCP, and we want to open this on port 8080. I'm also going to run this. So I ran the get services, and we could see it gave us a virtual IP of that, and this is mapping port 8080. I'm also going to run the get endpoints command. It's given us the name of the service and the endpoint. And you see it worked. Now notice I mentioned earlier, when you work with a node port, it exposes that port 8080 as 3226, which is what I have here, port 3226. So it allows you to open holes in your cluster that you can allow people to access your web server. Internally, that was the endpoint. It was that virtual IP and that port, but externally on that port. So that's why this was the master node, and then with that port I was able to open it. I should also be able to open this in my browser. And there you have it. We've used a node port and we've been able to open a hole at that port to access the web server. We need to do a cleanup. Always remember to clean the kitchen when you're finished cooking. Personally, I'd advise you to use this Nginx in your production cluster and also in your development and UAT clusters. You don't have the security risk of the container running as root. We have learned how to use kubectl commands to be able to deploy applications, to create services, to be able to expose the services so that we could open our web server or our application, in this case the Nginx Webservers, through the browser. We also learned that it was highly beneficial to use namespaces, and we saw the benefits when it came to cleaning up the cluster. We deployed 2 kinds of Nginxes using kubectl commands, and the last Nginx we deployed was one that was a non-root Nginx server. And we mentioned about the security risks of deploying containers that are running as root. One thing we need to remember, deploying applications on your Kubernetes cluster in a production environment using only kubectl commands is not a very good idea. It's actually a bad idea. The reason is that you don't get the repeatability that you get when you use manifests. And later you will also learn, in the next lesson, we will learn about using Helm charts. Thank you for watching this lesson. We trust you learned something and you found it useful. Please go below, give us a like, subscribe to our channel. We would love to get your comments. It helps us with planning our next videos. Once again, thank you.